I heard the participants here present themselves, I understood that maybe it wasn't me that should have the presentation of the literature review, but rather one of the librarians. But so I'll do my best, and if you have anything to correct or fulfill what I say in any way, so please do that. So what I would like to talk about is how we do the literature review in some of the project groups that I work with. And then we try to do the literature review in a systematic way. So we aim to identify, select, evaluate, and organize all available data of sufficient quality that is relevant for the research questions. And the result of this is often very comprehensive literature searches and with a lot of hits. But with a lot of hits, I don't mean like 50,000 or like that, but it could be a few thousand maybe. Not always that many either. So what we do when we have this a literature review that we want to do is we sit first down with the project group and we look into the question that we are going to answer. We work with the literature search strategy. We define the eligibility criteria for the literature, how we want to do the data extraction, which methods we want to use for critical appraisal of the literature, and finally then how we want to do the evidence integration and synthesis. And I think the 3 points at the top, the question, the search strategy, and the eligibility criteria, are the 3 points that is the most important for the literature search. And it's important that they are planned, justified, documented, and reproducible, and I will come back to that. So this was just to show that what we aim to find in the literature search is actually all relevant literature. So it would be ideal just to find this, the small circle, the relevant literature, but as you see, if you do a narrow search, you most likely lose a lot of the relevant literature, and if you do a wide search, then you get a lot of not relevant hits. So still we end up now mostly doing the wide searches because we think that the search strategy should be highly sensitive for us to identify all relevant literature. So we start with this one, the PICO or the PECO for us often. And what we fill in here is most often not all the letters. We always look into the exposure because that is what we have when we do a risk assessment of a chemical substance in food or personal care products. We have a substance that people are exposed to. So we have the substance and we have some kind of health outcomes that we want to find. Sometimes, in addition, we define the population, but most often we only identify the exposure and the outcome that we are looking for. So this was just to show you the steps that we have when we do the literature searches. So we start up to plan the search, we look into the PICO diagram, which kind of search terms to use. We get help from the library to do test search and to choose the databases, and not at least to make the final search strategy, because we are not experienced enough to do that ourselves. So as you can see, I have pointed out that both the project groups and one or more librarians are involved in this planning. And then when it comes to performing the search, the librarians do it all. So they translate the search into the syntax of the databases, they plot it, they export it and to EndNote, and they also remove all the duplicates. And so this slide was just to show how complex it is for us to do this and why we really need help from the librarians to set up a good search strategy. So when we get the search result from the librarians, we get an EndNote file, and what we usually do then is to upload the EndNote file into the software Ryan, and we use this software mainly just to be able to collaborate, as it stands here, to do the blind screening, because we are always two people that separately screens the title and the abstracts and then assess the full text articles. So this is why we use Ryan, which is freely available. And so when it comes to the documentation of the search, we normally always prepare a flowchart just to show how many hits we had, how many duplicates were removed, how many records were screened for title and abstracts, and then for the full text publication, how many publications did we assess and how many did we exclude, and we also document then the reason for exclusion, and then finally how many publications did we actually include. And what we also document then is that we prepare a table that gives an overview of all excluded publications, and it's only for the publications excluded in the full text evaluation, and we tell the reason for the exclusion. So for the included publications, we always then try to evaluate the internal validity of each study for each health outcome. And this was just an example to show you the questions we evaluate if it is a human randomized clinical trial, for instance, and how we do this evaluation. And then we end up with classifying the studies in tiers according to internal validity. And then, for instance, tier 1 will be studies with a low risk of bias, and tier 3 will be studies with a high risk of bias. And then studies with high risk of bias are not included further in the risk assessment. And then finally, this slide was just to show you then that we end up with taking all eligible studies with a low or moderate risk of bias for each endpoint, and we try to evaluate the confidence in the evidence for this specific health effects. So as you can see here, for instance, we have 7 randomized controlled trials addressing blood pressure, and the risk of bias was serious, but not very serious. There were no unexplained inconsistency, and so we have these factors that will downgrade the confidence in the evidence, and we have factors that will upgrade the confidence in the evidence, and then we will end up with an overall rating. And that will be the steps that we have in a systematic review. And so this was actually all my slides, and maybe someone have comments or questions. So I'm happy to do my best to try to answer that. Thank you.
Well, I have a question straight away, Gero, is giving the complexity of the process, could you estimate what kind of time would you use for, let's say, an average literature search?
I think that is quite hard, actually, because it depends on the number of hits. So we do not use a lot of time just to plan the search, but what we use a lot of time on is this here, to define and discuss and really have pinpoint the questions that we are going to answer. So we sit down with the project group and we discuss all aspects to make sure that the questions we are going to answer will actually give us the information we need to do the risk assessment according to the mandate that we have. And when the questions are ready, then it's quite easy to define the exposure and the health outcomes, and then to work with the library to prepare the search strategy. And they are very experienced in that, so it's not like this process takes a lot of time, but takes, sometimes it depends on how much time they have to help us. And then, of course, the whole process could take a lot of time, but that again depends on the number of hits that you get. So do you get 10,000 hits or do you get 500 hits? And what we try to do in a way to make the work easier is to have a kind of an evidence pyramid, so that we say, for instance, with the project that we have ongoing now that looks into caffeine and negative health effects for humans, we have said that the randomized control trials are the best evidence. So they will be on the top of the evidence pyramid for us. And then you have maybe human observational studies and animal studies and like that. And so when the literature search is done, the librarian have added a filter to give us first only the hits that are classified as randomized control trials. And that is a way for us to reduce the work. So I think it depends a lot. We have projects where it takes a lot of time, and we have project that is much smaller.
Thank you, Guru. I see Radoslav has a hand up.
Yes, I have a question. When you do the systematic literature review, do you have some templates which you then fill in while doing that? Because you have to provide some review report at the end, I guess. And yeah. Do you do that according to some template, or so there some guidelines how to do that?
Yes, we use guidelines, and as we could have both literature for, from instance, human studies and animal studies, we need guidelines that gives us that possibility. So we often use some American guidelines from something called OHAT. I think it's part of the National Toxicology Program. But then, of course, you could use the Cochrane guidelines. They are quite similar. And we have a lot of different kind of guidelines, and it depends a bit if we, for instance, look into systematic reviews, then we use, again, we could use other guidelines. So I think there are a lot of guidelines available, and also what is important, it is a lot of reporting standards telling you what you need to put into your report to make sure that it is a systematic review. So both reporting standards and guidelines, and it's available. So we don't find these things up ourselves. We use established guidelines.
Okay, thank you.
Thank you, Guru. I see Marit has a hand up.
Thank you, Guru, for this nice presentation. It's more or less in line with what my day looks like when I'm at work. I was just wondering, do you always also search for other questions than intervention studies like we presented that should be answered, of course, with an RCT, a randomized controlled trial, preferably if there exists one. But there are so many other, maybe more difficult questions that don't lend themselves easily to a straightforward process. So Do you have such questions, and how do you deal with those? Thank you.
I'm not quite sure that I understood what you mean, but I think that yes, we have complex questions from time to time, but we always try to break up the questions in smaller questions that we can answer question by question, and then it might be that we end up needing 4 different kind of literature searches to try to find the literature we need to answer the separate questions. Was that an answer, or could you specify what you meant?
Yeah, I'm just thinking that within the Cochrane group that I'm working, we are doing systematic reviews of effects. So we have an effect question, usually answered by an ICT, or if not an ICT, then you could use a control before and after study, or a time series studies, or a control study which is not randomized also, because the group that I'm working within deals with questions about health systems, so it's not clinical questions.
Yeah.
And those health systems questions can be answered by, effect questions can be answered by other study designs and ICTs, but we also do systematic reviews, for example, on questions that needs to be answered by qualitative research. And those systematic reviews, we call them QES, Quality Assessment Synthesis. And those questions cannot definitely be answered by ICT. So at least within our group, we have 2 different questions. And I know that Cochrane at large has also systematic reviews on diagnostic test accuracy, on prognostic questions. So I was just thinking that you also might have within your area, which I know nothing about, also could have a variety of questions that needs different approaches.
We have a variety of questions, but I think we always have, for me at least, we always have a chemical substance that is the exposure, and we always look into health outcomes, human health effects. And we always aim to either find or be able to ourselves to set a guidance value for human health effects. So a value that tells us how much of a substance could a man be exposed to without getting appreciable negative health effects. So we always aim to end up with a number, and then, as you see, it will be quantitative. So if we only end up with the studies that makes it possible for us to say that it could be health effects, but we don't know the amounts that are safe, for instance, then we are not able to conclude in the risk assessment. So, but yes, we do searches where we have all kind of human studies, case studies, other kinds of observational studies, and we have animal studies, and we also use in vitro studies. So we try to find then guidelines that makes it possible for us to do a systematic review, including all these kind of study designs, and that is quite problematic. But for research itself, it's not an issue, but for instance, when it comes to the evaluation of risk of bias in cell culture studies, it's quite hard because then there is a lack of guidance documents. Was that?
Yes, thanks a
lot. Answer? Yeah.
Thank you.
I can't see any other hands, but I would just like to answer to Marit as well, because in my area of work, which is the biological hazards, this is where we actually hit those problems that you were mentioning, Marit, because we usually have the agent that we are assessing. We have the health outcome, which is as few people as possible ill. And in the middle, we don't have any structured studies. We have information and data that would come from very different types of research. And it's very, very difficult actually to structure a search, because you actually have, as Guru is doing occasionally in her field, you have actually to divide your question into many parallel questions. So we normally would end up with a very wide search and then divide that big primary search into different ones according to the different steps in the risk assessments, and everything that has to be divided in parallel things actually makes the whole process so much more complicated. So we are looking very much forward to get that process simplified. Okay, if there is no other questions, I think we could go further on with the agenda. We are fortunately still ahead, a little bit ahead of the timetable, which means that you might have a little bit more time for the lunch and answering all those emails that have gathered in the meantime. However, we will start with the presentation of the project, and I will tell a little bit about the background for the project. The whole idea was actually emanating from the pilot project that EFSA, which is the European Food Safety Authority, has been doing on the automation of the literature search process and the systematic review process. They do hundreds of risk assessments a year. They have very extensive both time and human resource costs doing the literature reviews and systematic reviews, and they have tried to look into the use of artificial intelligence in trying to speed up, if not the whole of the process, at least some parts of it. They had a pilot project going for almost 2 years, and 2 years ago they have published the results, and those results have shown that they have come up with a tool that have automated parts of that project. Unfortunately, the testing of the tool has shown that sensitivity was not really very good. Due to both time and financial constraints, EFSA couldn't go further developing the tool, but a few countries have picked up on that in the advisory forum for EFSA, and we have tried to push on with the project. Fortunately, we were quite lucky, and Poland has managed to identify the financing for the project, and we have made a project proposal and searched the project from the EU related resources, and we have got the money. So we have developed a project that contains 6 work packages, and now I would like to invite Radoslav to tell us a little bit more about the whole project. Please, Radoslav.
Thank you, Danica, for introduction.
Right, we can see your screen.
Yes, thank you. And I hope that you see the first slide.
Yes.
Okay. So before I will present work packages, I would like to add to what you said about the circumstances in which we started the project. I would like to add that this project is funded by Norway grants, and that means that Poland has to be a leader in the project. So it's one of the reasons that Warsaw University of Technology is a leader of the project. The agenda for the presentation is as follows. We had the first presentation about the practical aspect of systematic literature review. I will look at systematic literature review from the point of view of designer of IT applications, which is going to support the process. So I will say a little about the process, how we recognize the process, what are features of this process, and how we could support by IT application the process. Then I will talk about automating some of steps of the process by using machine learning techniques. And at the end, as a summary, I will present project work packages to show that these work packages try to realize these two goals: to build IT application for systematic literature review as a first goal, and as a second goal, to automate some of steps of this process. As we look at the process of systematic literature review, we have to take into account the fact that that process must meet some requirements. This is important from the point of view of building IT application. I state in this slide also that meta-analysis is regarded as a part of systematic literature review, but I have to say that it's not in our proposal to support this part of systematic literature review. So, if we look at the systematic literature review process, the process is a kind of business process, and there are some tools for modeling the process. But when we model the process, we have to take into account some specific of the process. Some criteria must be met by the process. For example, literature reviews should be valid, reliable, repeatable. And moreover, at the end of the process, we have reports finding, which must be accurate and must be transparent to other people who will read that report. So, which means that means that we have to provide some, for example, forms which must be filled in, some templates which represent some forms which must be filled in by experts who do systematic literature review. And we have to base our application on some methodology. There are few methodologies, as far as I know. There are few methodologies concerning systematic literature review. The first probably is quorum, which was a quorum statement, which was published in 1999. And the quorum statement mainly concerns meta-analysis. But meta-analysis is a part of systematic literature review, so this quorum statement can be regarded as a first detailed description of the systematic literature review process. And the second approach to systematic literature review was Prisma, which was published in around 2008. And the Prisma statement was developed by a group of 29 people. Among them were reviewers, methodologists, clinicians, and so on. And the Prisma statement is quite a detailed description of a systematic literature review. It consists of 27 items, there is 27 item checklist and 4 phase flow diagram. The question is whether we should build our application around so detailed description of a systematic literature review. Advantage of doing that is that Prisma specifies in detail steps of a process. Disadvantage is that there are quite many steps in this description, and each step of the description requires preparing some form which must be filled in by experts which are doing systematic literature review. So here I present a less detailed description of a systematic literature review. The description quite similar to that what we have seen in the first presentation. This is taken from literature, and this description has 8 steps. Among them are such steps as searching the literature, screening for inclusion and exclusion, reporting. On this slide, I also show which steps of this process, described as an 8-step process, could be supported by a REFSA project. The first step, formulate the problem, in fact concerns the problem of defining questions to bibliographic databases. It's not written in our proposal that this step of a process should be supported by our application, but probably it will be, because it is quite important part of the whole process. Among other steps which will be almost fully supported or automated by our application is searching the literature and screening for inclusion and exclusion. So we have to remember that the process which I described as an 8-step process, in fact, has a feedback. So some steps of the process must be repeated. So I did this show on the slide. And the second issue which I would like to emphasize, which I have already emphasized, is that when we are doing IT application to support the process, we must be aware that some steps of the process require some templates which must be filled in by reviewers. And this is one example of a template. From the first presentation, I see that the question is whether we will use some general template, for example, for writing report, or there will be different templates depending on the kind of systematic literature review. So the first goal of our project is to support systematic literature review by IT application, and we are going to do that by modeling the whole process as a business process. We will use the standard approach to modeling business processes. This approach is based on BPM and business process modeling notation, and while doing that, we will state what are steps of the process, who is involved in each step, and each form must be generated at each step. So the first goal, we already started doing that. So we have some diagrams, VPM diagrams describing the process. Of course, these diagrams will be consulted with other partners of the project. And the second goal of the project is to automate some steps of the process. But before we show how it could be done, the first slide concerning this part of the project shows so-called manual screening process. So in this diagram, we have experts, at least 2 experts, which formulate the problem. In fact, they formulate some questions on the basis of which some papers are retrieved from bibliographic databases. So at least 2 experts formulate the questions. On the basis of the questions, some articles are retrieved from bibliographic databases. And in that way, we create so-called pool of retrieved articles. And when this pool of articles is screened by experts, and they decide whether a given article is relevant or irrelevant. So this is a fully manual screening process, and I assume that usually it is done in this way. Before I present how we could automate this process, I have to mention that the literature on that issue is quite large. There are quite many papers which show how we could use machine learning techniques to support systematic literature review. Most of these papers concern problems from medicine. And this follows from the fact that systematic literature reviews are strictly connected to evidence-based medicine. So there are case studies in literature on which some proposition concerning using machine learning technique to support systematic literature reviews are tested. There are also some case studies from EFSA. And this case studies follows from what Danica already said, that some time ago, 2 or 3 years ago, some project started funded by EFSA. And while doing that project, 3 case studies were created, and we can use in the beginning these cases to test our solutions. I have to emphasize that when we did systematic literature review for using machine learning techniques in automating SLR, we didn't find papers which could show how commercial software such as IBM Watson or Microsoft Azure could be used to automate the process. And by that I mean that I couldn't find a paper which could show that using commercial software would be beneficial, in the sense that I didn't find a paper which provides results of applying commercial software to some case studies which are present in literature, case studies which are used to test some solution provided by academics to automate systematic literature reviews. So one of the aim of the project is to verify whether using some commercial software could give better results than solutions which are provided by academics. And the other aim of the project is to provide some case studies related to food safety in order to to analyze, to verify effectiveness of the proposition which we are going to provide. So when we think about automatic systematic literature review, usually we think of fully automation. And by fully automated process, I mean the process which is described in this slide. So we have two experts which formulate the problem. These experts formulate questions which are passed to bibliographic databases, and on these questions, some papers are retrieved. And then there is a, let's say, black box in which some evaluation calculations are done. And these calculations are done based on knowledge of the domain in which this question is asked, and on the basis of some techniques used in NLP. So how it is done? So we have papers retrieved from bibliographic databases, and these papers are annotated using some knowledge. Usually this knowledge is contained in ontologies, one or many ontologies. And the annotation is done with the help of NLP techniques. So eventually we have a pool of so-called annotated articles. And these annotated articles are passed to one or many classifiers. And the classifiers decide whether a given paper, annotated paper, is relevant or irrelevant. The problem with this approach, this fully automated approach, is that it is not obvious how to build classifier, how to use, for example, how to use these annotated papers to provide parameters of a classifier without experts. So usually in the literature, partial or semi-automated approach is advocated. And in this semi-automated approach, experts are involved in building classifier. So again, we have annotated papers, so we have to go back to the previous slide. So we start from this point. The next diagram starts from this point. We have a pool of annotated papers. I remind these papers were annotated by using our knowledge contained in ontologies. And these annotated papers are then used to build a classifier with the help of experts. So some annotated papers are passed to expert, and they manually screen these papers, and they decide whether a given paper is relevant or irrelevant. So eventually, we have a subset of papers already labeled by expert. This is stated here as a subset of pool of relevant and irrelevant papers. And on the basis of this set of labeled papers, a classifier is built. Having a classifier, then we take all annotated papers. So it means all retrieved papers from or articles from bibliographic databases, and the classifier give so-called predicted labels to these papers. So the two sets of papers created. One set concerns relevant papers, and the other set concerns irrelevant papers. And this labeling is predicted labeling. So having all papers labeled, some of them which are dubious from the point of proper classification are passed to expert, and then they manually screen these dubious papers and give probably proper labels to these papers. And so a new set of papers for building the classifier is created. Probably some new papers from the pool of annotated papers are added, and a new classifier is built. And on the basis of this new classifier, all annotated papers are classified again. And this process, this feedback is repeated until some criterion is met. When this criterion is met, when there is no update of the classifier, and the last results of the classification are passed or create a pool of relevant and irrelevant papers. The question is when to stop this process of building classifier. In the literature, usually it is said that if after screening half of all annotated papers, we stop the process of building the classifier, this case is regarded as good support for manual screening. Of course, the problem is how to build the stopping criteria. There are several approaches for that. And moreover, how to measure efficiency of the whole process. Usually, they use some standard measures such as precision recall. And also a new measure is introduced called WSS, work saved over sampling. And this measure measures how much time we save over manual screening. So what I presented now is a standard approach used in automating systematic literature review. And summing up, because we have two goals in our project. The first goal is to build IT applications supporting the systematic literature review, and the second goal is to automate some steps of the process. And we have 6 work packages. The first work package is devoted to building IT application. This IT application should generate some templates which will be built in by experts. The second work package is a selection of data, bibliographic databases, and maybe some other sources of documents from which we will retrieve articles for systematic literature review. The third work package is concerning building scientific networks. And this package will be discussed later in these workshops. The question is, of course, how to use results of work package 3 in the whole context of our project, whether it will be a separate part of the project, or whether it will be integrated with the approach which I just outlined. Then we have so-called ontology building for food safety. That work package, in fact, concerns how to use ontologies in order to annotate the papers. In other words, how to use existing ontologies such as ontologies in medicine, snow-based city mesh, or ontologies in the domain of food, like food-on. How to use these ontologies in order to transform original article into vectors of numbers, and these vectors of numbers should represent semantic information of article. Then we have a fifth work package. This fifth work package concerns mainly building the whole classification process. And then we have a sixth package, which concerns system evaluation recommendations for their use in SLR. So shortly, this is a presentation of work packages of our project. A little more information is in our web page. The address is presented on this slide. Thank you very much for attention.
Thank you, Radoslav, for the short introduction to our project, and particularly thank you for giving us some nice and sunny pictures, because it doesn't look very nice and sunny at the moment around here. Now I would like to ask whether there is any immediate questions to Radoslav at the moment. I don't see any hands up at the moment. I can wait a little bit longer to see whether anybody is trying to digest and see.
I'm having a question.
Please.
Thank you very much for very interesting presentation. I was wondering, when you are building these classifiers, did you have any like parallel process or project that kind of to test this out, like if you understand what I mean, like one manual and one automated, and then you compare them and see if it works good or something?
Well, your question, I think, concerns the work package number 6, because at the end of the project, we are going to test our approach to see whether we missed some important articles or not by using this semi-automatic classification.
Thank you.
I suppose I can say a little bit more about that. The work package 6 is that part of the project that is going to look into the evaluation of the sensitivity and specificity of the developed tools, which means that we are going to use the ongoing literature research processes in our work and have a look at what results do we get by the traditional literature search, and then compare the results from the semantics tool and the citation networks to see how they compare with the view of sensitivity and specificity. I think our biggest concern actually is sensitivity, because we don't really want to lose any articles. I think any scientist working in the risk assessment would rather have to go through 10 articles more than losing 1 or 2. So this is our main concern. Of course, we don't want to have too much noise either. So we would look into which of the tools give highest sensitivity with the least possible noise. The other thing is actually that, and that has struck me actually through the discussions when we were preparing the proposal for the project, is that it's not necessarily that one tool is going to be perfect for every area. It could actually happen that, for example, semantics-based literature search that Radek is going to develop is probably more suitable for the studies and well-structured literature searches, while citation networks might work a little bit better for other areas, for example, like mine in the biological hazards, where we have very unstructured literature and very unstructured data. So we don't really know. We are actually looking forward to actually compare and see whether one thing works for everything, or we probably have to divide and use the tools depending on what kind of literature we are expecting. So it's incredibly interesting part of the work, and I'm looking very forward to it. Any other questions?
I have more of a comment.
Yes, Jostein, please.
So thanks for the introduction. This is and I also appreciate the question that was just asked. So as with any project, the proof is in the eating the pudding, right? So we need to make sure that whatever we end up with here is something that, or hopefully we end up with something that is usable. And whether or not it's usable, it's hard to evaluate before we're actually there. But of course, a lot of people have tried similar things like this, and there are numerous examples. So one was mentioned earlier today is from EFSA, where they developed this R package or R tool that you can use to sort of guide you in screening through the literature. And as Danica mentioned, that works reasonably well, perhaps, but you very often lose some scientific articles. And the way they've tested this is to do exactly as suggested here, is that you have a manual screening of the whole library, and then you take parts of it and train a classifier, see how it works. You take a bigger chunk, and then you can also get some information on how much manual screening you would probably need to do before a classifier would work. But in general, a lot of these approaches, they don't fail completely, but they do miss a lot of the relevant literature. And we need to be cognizant of that. We need to look carefully into the literature, look at what other kinds of classifiers have been used, what is the data that has been used as input into these classifiers, and try to not only build up the content of this project from scratch, but trying to look at what has been tried before and what actually does work. And there are many different ways of using the language, the natural language processing, like how many words do you take into account? Do you look at duplicate words? Do you only look at single words, 2 words, whole sentences? Do you look at words combining together when you look at the content of the papers themselves? So we need to make sure that we try to scan the relevant literature for this approach in itself, because a lot of people have tried this, and people are, or most of the attempts have been reasonably successful, but not successful enough that a lot of the researchers, at least within my field, would be happy enough to let them sort of outsource the screening of literature to some artificial intelligence machine. Thank you.
Thank you, Jostein. Radoslav, do you have any comment to that?
Yeah, the presentation, in fact, was based on the screening of existing literature on systematic literature review and how it can be automated. So what I presented is an approach-based active learning approach, in which some experts are involved in the process of building classifier. So of course we will take into account, and we take into account, what has already been done in the field. Moreover, it's not clear how to use semantic. We will start with some solutions which are presented in the literature concerning using ontologies in building classifier. But I think there are still in this area there are still quite many open questions. How to use information from ontologies in order to annotate the papers or articles, and use these annotated papers for in classification. So obviously we will start. We start on the basis of current state-of-the-art of this domain of using machine learning techniques to automate systematic literature reviews.
Thank you, Radoslav. I was just wondering whether you could say something about the approach that we have been discussing with the Slovenian Institute. Unfortunately, they couldn't be a part of the project, but taken into account how many different ontologies there are. We were actually discussing the possibility of using the tool that would actually compare those ontologies, because adding one more ontology didn't really look like a viable way. So maybe you could explain a little bit about that.
Yeah, that's right. I mean, one of the problem is how to use ontologies. When we look at using ontologies in medicine, you've got plenty of ontologies there. The two of them, SNOMED, CT, and MESH, are the most popular. Sometimes one of them is used, sometimes both are used, and so on. The problem is how to integrate ontologies. There are some tools like Robot, for example, which enable to put many ontologies in one place and use them to annotate the papers. So we are going to look at this issue, of course.
Excellent. Thank you very much. Any other questions to Radoslav? We still have some time before we can go for lunch, as the Ashley, who is presenting straight after the lunch, is the one who couldn't participate in the meeting before lunch. Unfortunately, we can't really start with the something else. So if there is no other questions, then I suggest that we break up for earlier for lunch. That would give you some time to have your lunch in peace and quiet and answer all those emails that have gathered in the meantime, since we have, we have a hand here. Hong Lian.
Oh, okay. Just one comment to what Jostein was saying. The good news are that we cannot also, by manual screening or manual information retrieving, we are never guaranteed that we can get all the papers anyway. So yeah, so like maybe the important thing that Radoslav said is when to stop. So yeah. I think it's good news.
Yeah, just if I can just comment quickly on that. Of course, this is absolutely true, and we cannot require that these techniques should deliver the whole package and do everything as we wish, because we have to compare them to what we would do, and we are of course fallible, and we miss literature, and we evaluate wrongly, and we shouldn't necessarily compare it to something that is optimal, but something that is relevant to compare it with, and that is fallible humans like myself going through the screening. Of course, that's a good point.
Yes, and that is exactly what we are going to look into at the work package 6, is that sensitivity and specificity, because sometimes actually what we experience as a noise could actually be a relevant literature. It's just because of our fallibility we didn't really recognize it as relevant. So we will really have to look very closely into the results and compare the usefulness, not to mention the time and the human resource that goes into the process. and try to find something that can do reasonably well and take a lot less time and a lot less human resource that we really don't have at our disposal. If I remember correctly, we had a meeting with the Danish Institute before the project was actually conceived at all, and I think they have estimated that they would use like a person month for a single for a smaller literature review, and that is really a long time. Not to mention that it costs a lot of money. So it's a lot of things we have to bear in mind when evaluating and the tools and giving the recommendations. Okay, any other questions or comments?
Danica,
Yes, Marit. Yes,
Yeah.
Marit.
I have just a question to the previous presenter about the kind of classifier. Are you thinking of classifiers that could read out a certain topic within your area, or are you talking about a classifier that could read out certain study designs that you would prefer to see in the screening process? I know that there are already classifiers developed for randomized controlled trials that seem to work well. There are classifiers to find other systematic reviews, for example. I'm most familiar with those developed by the Epicenter in the UK. So what kind of classifiers are you thinking of? Topic related ones or study design related ones, if you understand what I mean? Thank you.
At the moment, we consider classifier design for a particular study, for particular review, because the approach I presented, so-called active learning approach, starts from zero, in fact. So we don't have a classifier in the beginning, and we screen initially some articles, and on that basis, we start building the classifier. This is an interesting question because we also consider the case when we have some reviews related. So we could use classifier from the previous review as the beginning. But at the moment, we assume that for each study, we will build a classifier.
Okay, thank you.
It looks like the questions are coming up after a while anyway. So I would just like to ask, is there any other questions? If not, I think we could now break for the lunch. And if you come up with any other questions that relate to the presentations before lunch, just let me know before we start with the agenda after the lunch, and then we can take up those questions straight away. Okay, it doesn't look like there are any more questions coming at the moment. We will start again with our meeting at 12:30, and then we can take up any questions that you have come up during the lunch, and after that we will take the presentation on testing out Microsoft Academic Graph. And I hope you will have a nice lunch, and then see you again in an hour.